we had to use our brains to kind of figure out the measurement when we're using these rulers. These are analog measuring devices. That's an example of an analog measuring device. We used an analog measuring device in the lab on Monday. Can anybody tell me what that was? The round thing? Okay. Yeah, that's not a beaker. That's a graduated cylinder. Okay. Beakers often have measurement markings on them, but we don't use beakers for measuring because they're just not very good for that. The balance, though, is not analog. Okay. I'll explain what that is in a second. Give everybody a chance to finish writing these definitions here. Is anybody still writing these definitions? Okay. Can anybody look around the room and tell me of any analog measuring devices that are in here right now? Huh? Well, other than the ones I've already shown you, sure. I've already shown you the rulers. I'll give you a hint. It's in the front of the room. The clock. You have to figure out the time on these clocks. Anytime a clock has hands, you have to figure out the time. Hello? Uh-huh. Okay. All right. Thanks. Okay. So clocks that have hands are analog measuring devices. Okay. What about this measuring device right here? Okay, no. Okay, this is what we call a digital device. Okay, so that's our next definition. Those that display numbers for you. Yes, D-I-G-I. Ooh, gracious, that's not good. Digit. Yeah, T-A-L. Trying to do too many things at one time. I'm just coming here and I gotta get his stuff together and one thing or another. All right, so in the lab on Monday, were there any digital devices we used? Huh? Yeah. We don't actually call that a scale. It's called a balance. And there's a reason for that. Okay. Scales. You might have scales in your bathroom, but we don't have scales in the chemistry lab. Okay. I showed you my watch. Most of you have calculators that are digital. They show the numbers right on the screen. So those are digital calculators, okay? We don't have too many analog calculators. I have one in my desk over there. Digital devices are easier to use. So you have to figure out the final digit with an analog device, but with a digital device, you simply write down every digit on the screen. With a digital device, you write down every digit on the screen. That make sense? Any questions? All right. Rounding rules then that I just showed you. Those apply to both addition and to subtraction. Rounding for addition and subtraction. Come on in. Yep. You don't have a new schedule with you, do you?
Yeah.
Can I borrow it just a minute? And I put you back right there behind Ron. Ron, raise your hand back there. I'll put you on that desk behind him. I'll get you some other paperwork here in a minute. Right now we're just taking notes on significant digits, okay? I'll bring this to you in a minute, okay? So we're going to line the digits up vertically, very carefully, in nice, neat columns. This will count here. The way that most students make bad grades when it comes to adding and subtracting with significant digits is because they're not careful about lining everything up nice and neat the way your teacher told you to do it in 3rd grade. Okay? Do the math. And then digits in the answer. You got something to take notes with? You might write on what you can write. I'll have to catch you up on some of this, okay, later. In the answer that come from columns with empty slots. Are insignificant. And should be rounded off. Okay? All right, so back to our original example here. We had an empty slot above this 4. Now, you can't put a 0 here, because if you put a 0 there, you are lying about the precision of that measurement. On this measurement device, we didn't have any markings to the hundredths place. We didn't have measurement markings to the tenths place. So we couldn't reasonably estimate to the hundredths place. Without markings in the tenths place, you cannot reasonably estimate to the hundredths place. So if you put a 0 there, you're lying and saying we did have measurement markings to the tenths place and I estimated one more digit. So you can't put a 0 there, but you can put an arrow there. Okay? You treat the arrow just like a 0 whenever you're adding and subtracting, but if you put a 0 there, you're lying about the precision, so we do not put zeros there. Does that make sense? Okay. And all these rounding rules in addition and subtraction only apply to digits to the right. Okay? We don't have to worry about rounding off to the left, only rounding off to the right. Okay? So when we're talking about they come from columns with empty slots, their insignificance should be rounded off. This is only 4 digits on the right. Okay? Only for digits on the right. All right, so that's a lot of stuff to kind of throw at you at once, so we're going to practice a little bit now, okay? Any questions so far? All right. Hearing none, let's move forward. I'm going to allow you to work with a partner of your choosing as long as you can do so quietly, okay? I would rather you discuss it amongst yourselves if you run into a roadblock, and then if you can't solve it for yourselves, you can, and nobody else close to you can come and ask me, okay? That way I can help more people who really need it. Most of the time students can work it out for themselves, and if I have to come around to every single group, we won't get through it. So this is a way to get it done a lot faster and a lot more efficiently, okay? All right, so practice problem number 1. And you can use a calculator if you have one. You just have to show all your work on the paper. Yes.
Is that a 9? Right there? 9 o'clock?
Right there?
Yeah.
That's a 4. This is a 4 here. And here.
Is it
10.07. 100. That's 110.07. Oh, here 107. Okay. Yes.
You want us to put them in the order you gave them to us in, or?
No, because you can move adding. Well, you have to put the subtraction in order, but you can't. You can move the adding around any way you want to.
Okay.
All right. So that's 4 practice problems for you guys to work on.